Looking at homework from section 5.3, this is question number 18. The test scores for the analytical writing section of a particular standardized test can be approximated by a normal distribution, as shown in the figure. A. What is the maximum score that can be in the bottom 15% of scores? B. Between what two values does the middle 70% of scores lie? The mean of this curve is 3.8, and the standard deviation is 0.95. So we have two parts here. We're going to start with part A. We're trying to find the maximum score that can be in the bottom 15%. So the bottom 15% of scores means an area of 0.1500 lies to the left of our z-score. So we're going to look for that in the body of our table. Because 0.15 is less than 0.5, we need the negative side of the standard normal distribution table. We look for the 0.1500, but we don't find it. The closest value to it is going to be 0.1492. So we'll take the z-score for that closest value, and the z-score for 0.1492 is negative 1.04. We're not looking for a z-score here, we're looking for a score on an exam. So that means that we have to use our x value formula. X equals mu plus z times sigma. Now mu was given to us as 3.8, sigma as 0.95, and we just found the z-score of negative 1.04. So we insert all those values into their proper positions, and we'll multiply the negative 1.04 times 0.95. So this is 3.8 plus negative 0.988. When we add these together, we get 2.812. Rounded to two decimal places, the maximum score that can be in the bottom 15% is a score of 2.81. For part B, we want to look at the middle 70% of scores. So let's draw a graph to see the situation more clearly. We can see that we have 0.7000 in the middle of the graph. That's 70%. And there's symmetry in these normal curves. So if we can find the left-hand z-score, then we'll be able to find both z-scores because they'll be opposite values from each other. Now if there's 0.7000 in the middle, the entire area under the curve we know is 1, so the two tails combined should be 0.3000. And that leaves 0.1500 in each tail. Because of symmetry, that 0.3000 is cut in half. Well, that's basically what we just did in part A, because we were looking for the bottom 15% of scores, which was 0.1500. So that tells me that the z-score on the left-hand side is negative 1.04. By symmetry, we get that the other z-score is positive 1.04. So now we know the two z-scores, but we want to know what the actual scores for this analytical writing section of this standardized test are. So let's look at the low end of the central 70%. That's where we use the z-score of negative 1.04 in our x value formula. So we get 3.8 plus negative 1.04 times 0.95, which ends up being 2.812, and that's what we found in part A. For the high end of the middle 70%, we use the same formula, but now the z-score is positive 1.04 when we insert it into our formula. Multiplying that, we get 3.8 plus 0.988, which ends up being 4.788. So these values are supposed to be rounded to two decimal places. So the two scores are going to be 2.81, which is the low score, and the high score is 4.79. Those are your solutions, and that's your answer.